The Heisenberg's uncertainty principle states that the better we know about an object's position, the lesser we know about its momentum, and vice versa. This is true because everything in the universe behaves like a particle and a wave. Here's a wave. It has a wavelength, which gives us information about its momentum. However, we cannot assign it a specific position because a wave occurs throughout a region. Here is a particle. It has a better certainty of its position within this range. However, it does not have a defined wavelength.
To get a better graphical representation of a particle with both position and momentum, we have to mix both particle and wave properties together. This is done by superposing a number of waves of different wavelengths. As you can see, the waves will interfere constructively at some points and destructively at other points. By superposing a few waves, you get a graph where there are regions comprising of waves and regions whereby there is nothing at all. For a more accurate position of the particle, we have to superpose more waves, therefore more uncertainty in momentum. To get a more accurate momentum of the particle, we can only look at one wave and therefore more uncertainty in position.
Here's an example of Heisenberg's uncertainty principle at work. I have a laser which is firing down a narrow slit across the room. This slit can be adjusted to become narrower or wider. Now, as I make the slit smaller, you see exactly what you expect. The spot gets narrower and narrower until you arrive at the point where the slit is extremely narrow that you're almost certain about the position of the dot. But if you go any further, something strange happens. As you narrow the slit even more, the spot starts to spread out because the rays of light travel through the slit start to veer off into different directions due to them having different momentum. And that demonstrates Heisenberg's uncertainty principle. Heisenberg's uncertainty principle is normally written as del x multiplied by del p is more or equals to h over 4 pi, where x is the uncertainty of its position and p is the uncertainty of its momentum. And that is the Heisenberg's uncertainty principle at work.